Hello everyone. In this video we're going to be solving an equation. A is a given number and we're supposed to solve for x. If you like this video, please comment, like and subscribe and hit the bell button for notifications. If you don't like the video, please let me know why in the comment section down below. I appreciate all kinds of feedback and let's get started. So we do have this equation, the square root of a minus the square root of a plus x is equal to x, and we're trying to solve for x here. As I said earlier, a is a given number, so we're going to find our answers basically in terms of a. Okay, let's get started. A couple of things to notice here, first of all, is that x needs to be greater than or equal to 0, right? That's definitely a must. And then for that very reason, a also needs to be a positive quantity, because if you consider what's inside the radical, we have another radical that has a minus sign, and if a is negative, you're going to get a negative quantity. So a also needs to be greater than or equal to 0. So early on, we need to establish these so we can kind of go ahead and use those later. And let's go ahead and call this part y. Now, what do you notice? That y is equal to the square root of a plus x, and y is also greater than or equal to 0. So with all these conditions, we're going to go ahead and get started. And obviously, you probably noticed that by replacing square root of a plus x with y, I also obtained another identity, which can be given as the square root of a minus y is equal to x. Okay, so cool. I have two identities, and if I go ahead and square both sides here, I get y squared is equal to a plus x, and here I get a minus y is equal to x squared. So from these two equations, if you isolate a, from the first one, you will get y squared minus x, and from the second one, you would get x squared plus y. Since a is equal to a, we can basically say that these two are equal quantities. Now, so we get a nicer expression. Why? Why is it nice? Because if you put everything on the same side, this should be factorable. Let's go ahead and do that. So why don't we just put everything on the right-hand side? X squared minus y squared plus x plus y is equal to 0. Now, x squared minus y squared is a difference of 2 squares, so we can just go ahead and factor that as x plus y times x minus y, and this can be written as 1 times x plus y to complete the, whole picture. And then now we can take out x plus y, right? And we should be getting x minus y plus 1 as another factor. Here we go. Okay. So now our equation is much better because, first of all, at least we don't have the a in there. We have two variables, x and y, and we can solve this because it's already factored. So we do get two solutions from here, obviously, right? If you think about it, we're going to be getting the first one as x plus y is equal to 0. So this kind of gives us a solution, right? But let's think about when this is possible. So let's call this the first branch. So when is x plus y gonna be equal to 0? So if you consider the original expression, x is positive, y is positive, right? They're both non-negative quantities, in other words. So their sum can only be 0. I mean, only when x is 0 and y is 0, right? And this implies that a is 0. Okay, cool. So basically, we do have 0 as a solution when a is equal to 0. At the end, we're going to write the solution as a piecewise function so that you'll see everything together. So we'll put it all together at the end. But we know that x equals 0 is a solution if a equals 0. Okay? And this is kind of obvious because if you go back to the original one and replace a with 0, basically, you're just going to be getting the fourth root of x is equal to x, and that can only be satisfied when, x is 0. And of course, we have the condition that x has to be 0 anyway, so it can't be anything else. All right, cool. So this is one way, one of the solutions. The second branch comes from this one. So if you set that equal to 0, which means that x minus y plus 1 is equal to 0, which also means that y is equal to x plus 1. Okay, now, what is that supposed to mean? Well, if you go back to one of the original equations, like here and here, we've received two equations, remember? We had this one and this one. So let's just go ahead and use this one. Y squared is equal to a plus x. Y squared is equal to a plus x. So if you go ahead and replace y with x plus 1 here, then you should be getting x plus 1 squared is equal to x plus a. So this basically gives you a quadratic equation, obviously, right? But you got to remember something. X is greater or equal to 0, and y is greater or equal to 0, so on and so forth. So we have those conditions in place. Let's go ahead and expand this. This should give us x squared plus 2x plus 1 is equal to x plus a. And then we should be getting x squared plus x plus 1 minus a is equal to 0. Okay, now let's think about it. Here, if a is, suppose a is equal to 0. In this case, obviously, you're not going to have any solutions for this equation, right? Because it comes from the other one. Not because, but, you know, we don't get any solutions because x squared plus x plus 1 does not give us any real solutions. But not only that, if a is less than 0, basically you're not going to get any solutions from here, right? Because you're going to get a quadratic whose discriminant is negative. So what happens if a is between 0 and 1, right? So that's another problem that you need to think about. But if a is between 0 and 1, you're also not going to get any solutions because what happens is if you remember the original conditions that we had where x is greater or equal to 0 and y is greater or equal to 0, so we're supposed to get positive solutions here, right? But we see that we are going to be getting basically from here, let's go ahead and write this down and then, we're going to see how that goes. So between 0 and 1, there are no solutions. But what happens if a is greater than or equal to 1? So you may also think about it like what happens if a is less than 1, right? If a is less than 1, you're basically going to be getting an expression here. Again, that's going to make the discriminant less than 0. But if a is greater or equal to 1, which means that this expression here is actually going to be 0 or negative, right? Then we can talk about the non-negative solution because you know that x needs to be greater than or equal to 0. So from the quadratic formula, we're going to be getting negative b, which is negative 1, plus, because we're not considering the negative 1, b squared, which is 1, minus 4ac, which is 4 times 1 minus a. And then let's go ahead and simplify this. From here, we should be getting negative 1 plus the square root of 1 minus 4 is negative 3. And then we get 4a minus 3 from here under the radical. Divided by 2 is going to give us the x value. So if a is greater or equal to 1, this is the only non-negative solutions. So now what I'm going to do is I'm going to put it all together and write the solution set. That way you'll have it in one piece. Okay? So here's the solution set. And to write the solution set, I need to consider all different a values. That's why a is a given number, meaning that it could also be called a parameter, meaning that when you change the values of a, you have different solutions depending on the value of a, and sometimes you don't have any solutions, again, depending on the value of a. Okay, so that's going to be like a more comprehensive solution if you mention the values of a in those particular instances. So here's my solution set. The x is equal to 0 if a is equal to 0. We said that at the beginning, remember? I was talking about what happens if x plus y is equal to 0. That implies x and y are both 0, which means a has to be 0. Cool. If a is greater than or equal to 1, then we're going to get the only non-negative solution here. Remember, we found it by using the quadratic. And if a is less than 0, or if a is between 0 and 1, and you can easily verify this. If a is between 0 and 1, you can plug in some values or you can complete the quadratic, so on and so forth. You'll notice that we're going to get no solution from here. All right? So that basically concludes the video. Thank you for watching. I hope you enjoyed the video. I'll see you in the next one. Until then, take care. Bye-bye.